Welcome to qnawire.
All right. We were asked about the TLC, the position of a TLC plate in the developing chamber when it's immersed in solvent. Now, the important thing, or what they're pointing out, is that you don't want the solvent to touch your spots. And it's important that it not be touching your spots, because when the solvent touches your spots, they will start to travel in the solvent. They could dissolve into the solvent completely. They could travel, for example, if a wave of water or solvent were to crest up over your spot, it could alter the normal trajectory of your spot, right? Because you want your spots to slowly rise as the solvent level rises. Ideally, it'll be rising evenly up your plate. So this is not allowing your solvent to travel up the plate in a slow and controlled manner. It's also going to potentially lead to your spots moving anything other than straight up. This is what you want. You don't want something like that, right? Because you need to be able to tell how far up the plate it went. And if it travels to the side, then up, it's not going to be an accurate depiction of the RF, or the retention factor. Why is it recommended to use pencil instead of pen to mark your TLC plate? Well, your pencil is not going to travel in any kind of solvent. It won't travel in non-polar solvents. It won't travel in polar solvents. It's basically inert, or practically inert, right? Graphite is not going to travel on your TLC plate. Well, pens are typically organic dyes. They are organic molecules in some kind of solvent. So if you use a pen, it's a solvent filled with organic dyes, right? So it's going to create spots on your TLC plate that are actually coming from the pen ink. And you only want to see spots from your sample, not from the mark that you left to, right? You're going to spot a sample here and spot a sample there and possibly a third spot. You don't want the actual line you drew traveling up, right? That's going to confuse your results. So that's why you shouldn't use pen.